Hello students, this is Devarchana Raut, lecturer in computer science. From today's slide, we will be discussing about a new topic, that is stack and queues. We have already discussed some introduction part about stack and queues in our introduction chapter, that stack and queue both are an example of linear data structure. So in our coming slides further, we will be studying about how basically what are the properties of stack, what are the operations we are going to perform on stack, what are the properties of queues, and what are the operations we are going to perform on queues. So let's start. So at first, a stack is a linear data structure in which the elements are arranged in sequential order. The linear structure represented by a real physical stack or pile. We can take an example of stack, or we can take a real life example of stack for explaining stack is like a pile of plates placed over one another, or a pile of cards placed one over another. So this is an example of stack. Insertion and deletion of items of stack basically takes place only at one end. That is, if we want to insert another plate in the pile of plates, so we will insert it at the top of the pile of plates, not at the bottom of the plate. Similarly, if we want to remove any plate, we will be removing it from the top of the plate only. So this is an example, so that insertion and deletion takes place only from one end, that is the top of the stack. The basic concept can be illustrated by thinking of the data set, either taking an example of stack of plates, or a pile of books, or any pile of cards, or anything in one pile order. Okay, so that if we remove anything or if we keep anything, we just need to keep it at the top of it, or the top of the stack. This structure is basically used all throughout the programming. So now we will discuss about stack implementation. The basic implementation of stack is called LIFO, that is last in, first out. To demonstrate the way it assesses data, since as well we see there are various variants of stack implementations. So first we need to know what is LIFO, or what is last in first out. Last in first out means when the data elements are kept on stack, or are been inserted, or we can say added to the stack, it is only added at the top of the stack. And similarly, when it is removed from the stack, it is only removed from the top of the stack. That is, the last element that would be inserted, that will be the first element that will be deleted out from the pile of stack. So we can say the basic implementation in stack, that is either insertion or deletion, is of LIFO category, or last in first out category, or first in last out category. So here are some basic operations that can be performed on stack. They are push operation, which means inserting an item in the stack, that is insertion of an element in the stack. Pop operation, that is deleting an item from the stack, or deletion of a item from the stack. Next is peak or top, that is displaying the content of the stack or the top of the element of the stack. Next is a full function which checks if the stack is full, and there is a empty function which checks if the stack is empty. So this is the stack representation. The following diagram depicts a stack and its operations. That is, the data elements are being arranged one over each other. So when push operation is done, or we can say insertion operation is done, data elements are kept one over each other. So first data element is inserted, next data element is inserted, next data element is inserted. So the insertion operation is push, we already know about that. So data elements are inserted from the at the top of the stack. Similarly, when we pop out or when we delete any data element, similarly we delete it from the top of the stack only. So pop operation also performs at the top of the stack, as it is a LIFO concept, last in first out. The last element that would be inserted or pushed, that will be the first element we will be deleting or we will pop out. So next we will move to array representation of stack. How is basically a array is represented in memory. In most high level languages, a stack can be easily implemented either through an array or a linked list. So we will be discussing about the array implementation basically here. The array implementation aims to create an array where the first element is at the bottom part. So that is when the insertion is done or when a element is pushed into any array, that is done at the very bottom state, or we usually say it zero offset. So that is, we already know in array, in our previous slides we have discussed about array. So basically our array first position starts with 0 index number, and we basically represented it as array of 0, where array is the name of the array and 0 is the 0th position or the first position. So here also, when in stack, when the data is pushed, so it is the first element basically stores in A of 0th position, that is the first element is pushed in the stack. And the similarly, when next element is pushed, it is pushed over the first element, that is array of 1, third element is array of 2, fourth element is array of 3, and so on. The push operation is used both to initialize the stack and to store values to it. And the pop operation basically decreases the size of the stack by 1, as it pop out one element from the stack and the size of the stack decreases gradually. So here we can see the example of push and pop operation in a stack, in which first 6 is been pushed in the stack, then 7 is been pushed, then 2 is been pushed, then lastly 1 is been pushed. Here we have a command of inserting 4 or pushing 4 in the stack. We already know we have to do the insertion at the top part of the stack. So we have inserted 4 over 1, that is 4 is now the top element. If we will be deleting any element from the stack, similarly we have to delete it from the top part only. Okay, so the top element was 4 and 4 was been popped out. This is how basically the push and pop operation are being implemented on stack. And the array representation of stack is just done simply as we put elements in the array, that is the first element in array of 0th position, the second element in array of 1 position, third element in array of 2 position, and fourth element in array of 3 position, and so on. So this is all about the basic introduction of stack and how the elements are being pushed and popped from the stack. In our next slides, we will be discussing about the algorithm of insertion and deletion in stack. So this much for this slide. Thank you.